at the beginning of chapter 7, we had to take our time because hypothesis testing was very new, words you'd never even heard before, probably. And now what we're actually going to go and do is we're actually going to use it. And so we're going to start off with testing for the mean. We're going to see if the average is good. And we're going to start with large samples. Okay? And when we say large samples, we're considering that 30 or more. Okay? And you can probably figure out why 30 is used from previous chapters that we've done. So before we do that, before we actually go and do a test, let's make sure we can find that rejection region we've been talking about. And what we're going to do is we're going to find critical values to help us out with that. And if this is going to be a large sample, where can I look for critical values? Where would be the place? Should I look at a chi-squared? Is that what I'm looking for? Well, no, that's not for the mean, right? What can I look at? I can just go for z-scores. I don't have to do t-scores, right, because we're good. We can just go ahead. We can find some kind of, in this case, it means a z-score, right? But now we have to figure out, well, what does that look like? This one is telling me that the test, because remember we had to figure out if they were left-tailed, right-tailed, and all that stuff. We did that in the first chapter. I'm just going to tell you right now it's left-tailed. And I want that left tail to have alpha of 0.01. Remember, so it's left-tailed. So basically over here, I want 0.01 in there, correct? You with me on that? And remember, alpha is basically the chance of having a type 1 error, right? Because we really don't want to have one, or we want to minimize the chance of having one, okay? But with a large sample, we can kind of make that a smaller value if we want, because a large sample is going to be pretty good. And so what we're going to do then is if you know we're going to use a z-score, and we know what value I have to find, well, how are we going to find the actual z-score? We're going to use our table. Okay? And which table should we use if you're looking for a z-score? Should I use the chi-squared table? The standard normal distribution. Very good. And so let's get that up here so we can take a look. Of course, I only have part of it here. And let's face it, if it's left-tailed, right, we should know it's a negative z-score, right? Quite a bit, probably, because there's not much area in there, right? 0.01. So it's going to be over quite a ways. So we should even just start on the negative side of our table. And then, well, you notice here I've got -2. Oh, I don't have the values up above, but that's fine. I can fix that for next year. So if we're looking for 0.01, well, I'm looking at this one here. This one's a little big. Can I do better than that one? Can I get closer to 0.01? Yeah, actually, there's one here that's pretty close, isn't it? See, if I go, it's kind of in between those two, correct? But this one here to 0.01, do you agree that one's pretty close, isn't it? And that's -2. I believe this is 0.0, right? 0.1, 0.2, 0.3 on top. Is that correct? Is that what yours says? So would you say it's -2.33 for a z-score? Yeah. So I'd say we can go with it's approximately -2.33. So in other words, I'll leave that there. That is the z-score that's right here. So what if I do the problem and I get a z-score of -2.5? Degree -2.5 would fit right in there, correct? Right, -2.5 for a z-score? So then I would reject the no, right? What if I got a z-score of -1.5? Well, that's right about there, correct? Is it in the rejection region? No. So am I going to reject the no? No, I can't. Notice in all of that, did I say anything about the claim? Because it all depends on where the claim is, remember, right? So we're just saying, can I reject the null or not? Okay, so everybody go with that. So all we have to do is find this value right here so we can compare our stat to it and find out if we reject it or not. Okay, questions on that one? Let's try another one. Gets a large sample, so we can use z. So now it's right-tailed, okay? So again, critical value, we know it can be a z-score. It's right-tailed, and alpha is 0.04. All right, so it would look something like that. Over here is 0.04. What you could say over here is what? Over in this white area, 0.96, right? Okay. Because I don't think if we look in there, we're going to necessarily find 0.04, right? Because how does the standard normal distribution table fill in? It fills in from the left, right? So we're going to be looking at a positive z-score for sure. So we should start on the positive side of our table, without a doubt. And I have taken the liberty of finding a narrowed down area. And so again, I can't really look for 0.04. You could though. If you look for 0.05, you'd be on the negative side and then just do the opposite, right? Or you can just say, okay, let's just go find 0.96. I'd rather you think of it this way. So let's see, 0.96. Let's find one that's pretty close. Well, it's kind of in between again, isn't it? Let's see, it's in between these two, right? So this is 0.0, 0.1, 0.2, 0.3, 0.4, 0.5, right in that region somewhere, correct? Are you with me on that? And so we would pick one or the other. Normally what you would do, you just kind of pick one, it'd be fine for here. But if we really wanted to be sure, what we would probably do is go to the further one, because then when we do our test, we'd be for sure, right? So you could say 1.75 or 1.76, either one is fine. Because really, that's pretty darn close, isn't it? So I think 1.75 would be fine. If we really, really want to test it out, we go to 1.76. But I'd say our Z critical is about 1.75. So again, what that means is that that's this leading edge of that rejection region. So if I get a Z-score that's beyond that, we reject the null. If I get a Z-score that's anywhere over here, we can't reject. But if it's over here, we reject it, right? So I told you, you've done a lot of this stuff before, finding these areas in the table, So why don't you go ahead, I'm going to stop talking here for a second, and I'll pause the recording and let you try this. All right, so I was a little mean on that one because I wanted to see if you just remembered the number, because this is one of them that you could potentially have remembered from the normal distribution pages. I look at it this way, is that it is 5%. So in other words, 95% has to kind of be in the middle, right? And that's how we did all our tests before. If it's two-tailed, we want 95% in here, right? And then 2.5 on each edge, right? But I kind of had you memorize that number for 95% if it's two-tailed, right? So hopefully when we look this up, it'll make sense. So you have two options. You can just go ahead and look up 0.025, right? Because this should be very symmetric with the mean in the middle, right? So just look up 0.025, or if you're not going to look that one up, you would look up, what value should I look up if I wanted to find the Z-score over here? 0.975, right? Because it's 97.5, right? And so let's see what we can find out. I don't remember which one I put on here. Well, it looks like I went for the negative. So I'm looking for 0.025 because the negative one would be this one over here. So negative 0.025. Let's see if we can find that. 0.025. Oh, look at that. Happens to be right in there. And I know this is 0.6. Okay. Because it's negative 1.96. Because again, there are certain values in here that match up really nicely, right? So if that's negative 1.96 over there, then what's that one over there? If this is symmetric, it's got to be positive 1.96. These are your two Z critical scores. Again, meaning if I do the test and it falls out here, I reject. If it falls out here, I reject. If it falls in here, I can't reject. Right? That's kind of how it goes. So any questions on how to set it up or find the critical value, which is kind of the leading edge of your rejection region? No? All right. Well, let's try one then, from beginning to end. So we've got a large accounting firm. The mean salary is less than that of its competitors, is what they're trying to say. And their competitor is $45,000. So a random sample of 30, imagine that they did 30, of the firm's accountants has a mean salary of 43,500 with a standard deviation of 5,200. So at alpha, again, the chance of having a type 1 error is 0.05. Test the claim made. Right, because we're going to have to figure that out. And where do we look? The question was, it doesn't tell us if it's right or left-tailed. How do you find out if it's right or left-tailed again? You look at the alternate hypothesis, right? Okay. Well, if we're going to test this thing, we've got 30, right? So we're good. We can do that. All right. So what we're going to have to do is we're going to have to set up and say, all right, I've got a null and I've got an alternate. And a lot of times what I do is I kind of figure out, let's read it and say, okay, the mean salary is less than that of its competitors. I always kind of read the claim first and figure out where to put that. And the words that are clear here, it says is less than, correct? So this is just going to go in which one, the null or the alternate? Alternate, right? Because there's no equal to on it. And what, and really we're trying to find mu, right? Is basically less than the competitor, which is 45,000, correct? And then the reason I always find the claim first is because then I know wherever I put it, the other hypothesis has to be everything else. Okay? And to get everything else, we're going to go and do that. Are we in agreement so far? Okay. Well, now we have to look and figure out what tail we're looking at. And we look right here. So it's in the alternate. It's always where you look. So what type of tail are we looking at? Just left tail, right? Does that make sense? Well, yeah, I want to be able to do that. Now, where's the claim in this again? I probably should have written that down. It's in the alternate, right? So the claim's here. We'll make a little note. So will I be able to reject their claim? Nope. The only thing I'll be able to do, possibly, is support it, right? Because it's in the alternate. Okay. Well, we're off to a really good start. Now what? Well, we should probably figure out where's this leading edge over here, right? What Z critical am I looking at for that leading edge? Okay, so we're going to go to our tables, and it's just going to be a left tail. And so I'm going to actually look up. See how I stuck another 0.05 in there right away to see if you're going to use that same value? But that 1.96 was for a two-tailed, right? Okay. So let's see what we've got. Let's bring this up. So 0.05. Well, we know it's negative, so we got to find 0.05 in this thing somewhere. And 0.05. Let's see, where is it at? Well, it's kind of stuck between a couple of them, isn't it? Kind of in between these two, right? But I'd say they're pretty darn close, don't you think? I mean, it's not that far off. Okay. Let's go ahead. Should we just split the difference then? Because it's kind of right in between the two. So this is 0.0, 0.1, 0.2, 0.3, 0.4, 0.5. So let's use our Z critical, this one right here. We'll say is negative 1.645. Should we just use that? Now, if you're going to write this up for somebody, you have to explain. We would probably go more in depth at finding a more exact value for that, right? But we're just trying to test this out and see how it's going. So that's our critical value. Okay. So far, we've pretty much set up the hypothesis. Okay, so we're doing good. And I'm going to get rid of this because I need the room. Okay. Well, now, really, we've just set up the test, haven't we? We haven't really tested anything yet. So what I need to do is I need to find out, well, what's the Z-score for the information they gave me? They gave me their mean. They gave me their standard deviation. This is for a sample, correct? So in other words, if this is Z, I'm looking for that. What is that Z-score for that sample mean? And if you remember, and this is kind of on the other side of your notes, we didn't talk about it, but we take the sample mean and subtract, okay, the mean, like that one, right? All over now. Remember that this is just whatever you had size X bar. And where does this one come from, really? If the sample's big enough, you just take that other mean you're looking at, right? For us, it's 4,500 in this problem, right? So really, we can just say minus mu if you want, or however you want to write that. But how do we get this? Does anybody remember that little part? The standard deviation for a sample mean. Very good. And you said S divided by square root of n because we can actually use S if it's over 30, right? We can use the sample. Where if it's not, we're kind of stuck and we have to use that sigma, right? Where here, you're right, we can use S if we want, which is the sample standard deviation. So hopefully the memory is kind of, oh yeah, I remember that now. We've done that already. And what we're going to do is we're going to find this z-score and we're going to compare it to that negative 1.645 and see what happens. So let's do that. So what's the x bar that we have here? Well, it's the 43,500, right? That's what they told me theirs was. Whoa. Got to write the right numbers, though. Minus the mean they would like me to compare it to, really, or the mean that we have here, which is 45. So at this point, we know it has a chance, right, of being in that rejection region because we know it has a chance of being negative. Agreed? Okay. Over, excuse me, 5,200 divided by the square root of n, which is 30. Okay, so go ahead and let your calculators go on that one, and we'll see what we get. All right. Now be careful with your parentheses and everything, right? What's that? Oh, yeah, you can do that too. Yep, do it separately. And what did you come up with for your z-score? Yeah, that's what I got. I got this to be, this right here is, the z-score for this is approximately negative 1.58. Okay, so we set up the hypothesis test. We found my z-score. Now we have to interpret it. Negative 1.58 falls right about there, correct? Do you agree with that? Is it in the rejection region? No, it didn't quite make it, did it? But darn close, right? So we would have to say, basically, can we reject the null hypothesis? In this case, can I reject the null? Did it fall in the rejection region? No. So basically, I can't reject the null. Which means I would say at 5% level of significance. If you're on like the AP, you might not want to abbreviate that. Okay. 5% level of significance. We don't have enough evidence to do what? Exactly, support the claim. I don't have enough. Had I rejected the null, I would have been able to support their claim at 5% level of significance. But here, I can't. Okay, the question was, if the claim was actually in the null, would we have been able to reject the claim? Nope, because I wasn't able to reject the null. So this particular test really is very inconclusive either way. Because if it doesn't fall in the rejection region, there's not much you can do. You can just say, at the level of significance you gave me, I do not have evidence at this time that can really do anything, but they like it to be more specific. Well, what could we have done here? We could have supported the claim, but because it all boils down to the claim. Now, why do you suppose? I was a little suspicious. I knew it was going to be close at the beginning because it started at 43,500, but the standard deviation was 5,200. So that means there are quite a few people that have over $45,000 salary, correct? Quite a few, but more of them that are less, right? So I knew this was going to be close to begin with. Okay. But if you look back, that just means too many of them were over 45,000 is really what happened for me to be able to go and support their claim. They were close, but at the level they gave me, not quite. Okay? Let's try another one. And then I think that's it for today, right? Yeah, well, we'll finish these other two tomorrow, maybe. They're not that hard, really. The U.S. Department of Agriculture reports that the mean cost of raising a child from birth to age 2 in a rural area is $8,390. This is old data. but it is actually data. It's old. You believe this value is incorrect. So you select a random sample of 900 children that are age 2. It's kind of important. To find that the mean cost is 8,275 with a standard deviation of 1,540. Add again 5% level of significance. Is there enough evidence to conclude that the mean cost is different from 8,390? How do we start the last one? Yeah, why don't we figure out null and alternate and see where everything goes? So first we got to find kind of the claim is what I look for, and then I put that down first. Mean cost of raising a child from birth age 2 and world is 8,390. So where does this one go? It has to go in the null, right? So it's the mean is 8,390. So the alternate is that the mean is, remember, you got to catch everything else, is not. Now here's a tricky one. I like this one because it is kind of tricky. We have to decide. There's a couple of claims here, right? So they're saying it is 8,390, but I'm saying I believe it's incorrect, right? So where's actually the claim? If I'm trying to test my own, I'm saying I think it's incorrect. That's what I'm trying to test. So I'm claiming that the mean is not 8,390, correct? So this is really where my claim, because this is what I'm trying to say, is actually in the alternate. Because I'm trying to test what I say, not what they say. Okay. So will I be able to reject the claim in this problem? No matter what happens, will I be able to reject the claim? Nope. Can I support the claim in this problem? Yep, that's all I can do. Right? So now we have to figure out, well, what did we do last time? What's next? What formula? I don't think we went to the formula right away. Yeah, we had to figure out, what do we have? It's two-tailed, right? Over here, over there. And 0.05 total, so it's 2.5 here, right? 2.5 here and 95 there, right? And we talked about this one earlier, right? So we know that these values, we already know that the Z critical is basically positive and negative 1.96, right? We kind of figured that out already, those leading edges. Okay, so now we've got to go and actually find out our value. Okay. All right, so we are saying in our sample, what do we find out? Our sample mean was the 8,275, right? So that's X bar minus the mean that we're comparing it to, right, which is 8,390. So right away, we know which of our two critical values we're going to be trying to surpass, right? The negative one, right? Because we already know it's negative at this point. All over. Now notice I didn't write it this time to see if you could remember it. What goes on the bottom there, that standard deviation. Well, we go ahead and we take the sample, which is S, like you said, which is 1540, right? And divide it by, square root of 900, or as somebody was going to say, you come up with that. You'd be close, okay? Square root of 900, or in other words, it actually ends up being 30, but I don't want to confuse you with the last problem having 30 as n and all that. So maybe just however you need to type that in to figure out what we're looking at. And what do we find out? Well, we know it's negative, right? How much? Negative. Or did I rush you too much? That's what I got. Okay, negative 2.24 is also what I got. Okay, so now we've done all this work. So now we have to, interpret this word. Yeah, this one falls, because remember, this is negative 1.96, right? With this being 0, right? And so negative 2.24 is over here. It's in the rejection region. So this null just got rejected, correct? So I would say something along those lines to start. Null is rejected. And now we have to figure out what that really means in this problem. We support the claim. So we would say, well, what does it mean to support the claim in this problem? To support the claim really says that the average amount for raising a child is quite a bit different from 8,390, right? Isn't that really what it's saying? Because that was my claim saying that it was wrong. Okay, so here's what I have written here. I said that the cost of raising a child from birth to age 2 is significantly different from $8,390 at 5% level of significance. So really I'm saying there's only a 5% chance of a type 1 error. Okay? And so you could always say support the claim, but you got what am I really supporting here, right? The null gets rejected, and then you find out where was, okay, so that's why we always write down where the claim is first so we don't get confused. You know, and so let's say the claim was in the null, then we would say that the claim, that particular claim was false. Okay, but we basically, I made the claim in this one, or like I said, you made the claim that it's different, and so you actually made a claim that was in the alternate based on that one. Okay, so you see how in this case I'm actually rejecting their claim because I made the opposite claim as to what they said. Okay, and the next two really won't take us very long tomorrow. It's just looking at it a different way, and it's a very common way of looking at it because it a lot of times takes a little less work. I can use your calculator, and so it'll help you understand. It's basically doing the same thing, just a little bit differently.